I think the universe is very complex. And I don't think it gives up its secrets easily at all. And I think the universe is full of fundamental trade-offs. Like you can't have both. You have to choose A or B.
Yeah.
And so these models will align with those fundamental trade-offs, right? And maybe it's performance, maybe it's correctness, maybe, whatever it ends up being. And so as soon as you want a specific solution for a given problem where it hits one of those trade-offs, you're just going to need a different model, because otherwise you just can't end up having both. And again, because I know the coding space the best, we see this a lot, right? Which is a model that's very, very good for certain parts of code is just not going to be generally good at other things, because those are the trade-offs made when training it. And I think that this is kind of the future plurality of model.
Well, is that true? I thought somebody said something, I may be wrong about this, but I saw some counterintuitive result that said that making the AI specialize in one area makes it worse in other areas. Did you see something like that?
Well, yeah. I mean, this is a very big debate, but the debate goes as follows. Like the first wave of AI was pre-training, where everything you threw into it, like it just got smarter. And so that's kind of a 10 for 10 technical win, right? Just because it'll be as good as writing code as sonnets. But as soon as you're doing RL, where you're training it in a specific domain with a specific verifier, you're likely losing, other areas. So you make it really, really good at playing chess, it's going to be less good at, something else like that, writing piano scores or something. So I think the current debate now and the current data seems to suggest that RL doesn't generalize in the same way. And so now we are in this case where you would have a plurality of models, because you're always kind of robbing Peter to pay Paul when you make it good at a certain domain.